Yesterday we demonstrated how to program the BrickPi3 to interact with the EV3 infrared sensor in beacon mode. In beacon mode, the infrared sensor measures light generated by the beacon. This enables the sensor to determine the distance between the sensor and the beacon. But this sensor can also measure distance without a beacon, transmitting light waves that are invisible to the human eye and measuring how long they take to return. This is called proximity mode. And that's what we'll be demoing today. The ultrasound sensor is actually more accurate than the infrared sensor measuring distance this way, especially because infrared measurements can fluctuate in various lighting conditions. They aren't as accurate in sunlight, for example. In real life, infrared sensors are less expensive than ultrasound sensors, so if accuracy is not extremely important and cost is an issue, you might opt for the infrared sensor to measure distance. Programming the BrickPi3 to react to the infrared sensor in proximity mode is easier than what we did in the previous video with beacon mode. In this demonstration program, we'll instruct the BrickPi3 to keep track of objects in front of it and turn left whenever it gets too close to one. As we did in the previous video, we'll begin by importing BrickPi3 to give us access to the sensor and the motors. And we import the Python time module because we'll be calling sleep. We create an instance of BrickPi3 again so that we can access the sensor and motors. And we store the sensor and motor ports in variables so that we can access them later. The sensor again is on port 4, and the left motor is on port B, the right motor is on port C. But in this statement, where we set the sensor type, instead of EV3 Infrared Seek, we use EV3 Infrared Proximity. We'll set up our motor speed. I played with some numbers and 75 worked out well. And this proximity limit is how close we want to allow ourselves to get to an object before we turn left. It's a bit of an arbitrary number. It's a percentage of the range of the sensor, which changes from environment to environment and from lighting situation to lighting situation, but 40 worked out good for us. Next we define a turn left function. When we get within proximity limit of an object, we're going to turn left to avoid hitting it. We'll call this function to do that. And we turn left by making the left motor go backwards while stopping the right motor. So here you'll see the left motor speed is minus motor power and the right motor speed is 0. But generally we expect to be going straight in the program, so here we've got the left motor and the right motor both going at motor power speed. And then the program itself is very simple. We have a forever loop where we interrogate the sensor, and the sensor returns a value that indicates the distance of any object it found in front of it in terms of a percent of the range of that sensor. So if the range of the sensor is 10 meters, then if it returned a 50, that would mean it found something 5 meters ahead of itself. So if the sensor determines that it's within proximity limit of an object, it'll turn left until it's not. And then it'll go straight, and since we're in this while loop, it'll continue doing that until it gets too close to an object again. And the process will repeat until we end the program by typing Control-C at the keyboard. If we get any hardware errors or sensor errors or any errors at all, we'll just ignore them, just to keep the program simple. And once we do press Control-C, the control will fall down to this reset all statement, which will stop the motors and return control to the system. So normal speed testing worked out fine. And I set the motor to a faster speed. It's a little bit of a herky-jerky ride, but that worked out fine too. Some confined space testing. Infrared light is usually invisible to the human eye, but you can see it here on video. And we don't just look at the performance, we look at the numbers also on when the program's running. We print out some diagnostics and make sure that the numbers look like they make sense. Sometimes what you see visually isn't what's really happening inside. Get some first-person shots. So that's the demo.